In this problem, we have a portfolio of cancer research projects. And so we're told that our portfolio has 150 research projects, and each project is expected to return 10%. Moreover, the standard deviation of these projects is very high, 400%, and we're also told that we can consider these projects, the returns of these projects, to be uncorrelated. And so the correlation between the returns of any two projects in the portfolio is equal to 0. And so we're told that our portfolio has an equal investment in each one of these projects, and we're asked to calculate the expected return of the portfolio and the standard deviation on the returns of the portfolio. So the first thing that we're going to have to do is calculate the weights on each one of these projects. Again, because there's an equal investment in each one of these projects, all the weights are going to be the same. And because we have n projects, all the weights are going to be equal to 1 over n, where n is equal to 150. Now we're ready to calculate the expected return on the portfolio. So recall that the expected return on the portfolio is going to be a weighted average of the expected returns of the underlying projects in this portfolio. And because each project is expected to return 10%, this weighted average is also going to be equal to 10%. Now we're ready to calculate the variance of the returns of this portfolio. So recall in lecture, we saw that in this example, the variance of the returns of the portfolio is going to be equal to 1 over n times the average variance plus n minus 1 over n times the average covariance. So in this case, the average variance, because all our projects have the same standard deviation, is going to be equal to this standard deviation squared. And so it's going to be equal to 4 squared, which is equal to 16. Moreover, because all of the projects in our portfolio are uncorrelated and their correlations are all 0, the average covariance is also going to be 0. And so now we can plug these numbers into our formula for the variance to calculate the variance of the portfolio returns. So in this case, the average variance is 16. So we get 16 over n. And our average covariance was 0, and so we add 0. So this is the variance of our portfolio's returns. And now the last step is to take the standard deviation, is to calculate the standard deviation of our portfolio's returns. And so to do this, we have to take the square root of the variance that we just calculated. And so in this case, the standard deviation of our portfolio's returns is going to be equal to 4 over the square root of n. And when n is equal to 150, this standard deviation is equal to 32.7%. And so notice that the riskiness of this portfolio, as measured by a standard deviation, is much smaller than the standard deviation of any of the projects within the portfolio. So again, this result is due to the power of diversification. And in particular, because we assume that these projects are uncorrelated, if we keep adding more projects to this portfolio, the standard deviation is going to continue to decrease. And so in the problem set, we ask you to see what happens to the standard deviation of these portfolio returns in the case where these projects are in fact not uncorrelated, but they actually have some positive correlation.